Wow. I'm only a day and a half behind right now. Woohoo! All right, so instrument navigation. I'm going to go through a lot of this stuff pretty fast because it's a review. There's only going to be one or two items here in this VOR stuff that hasn't already been covered. So we're going to talk about very high frequency omnidirectional range. Everybody knows what the abbreviation for VOR stands for. The frequency starts at 108. That's where FM stops. I'm not going to ask you that on the test. But the highest FM radio frequency is 107.9 megahertz. And then VOR frequencies and localizer frequencies, we haven't got to it, but there are airports like at the Fresno Yosemite that have effectively what's kind of like a VOR transmitter, except it's more sensitive and it only has one radio that it transmits for. So when you're flying that localizer, you can actually spin the OBS knob and it doesn't change anything. It's like if you're landing on runway 29 right and that radio is coming out on an inbound magnetic course of 287, we're going to spin the OBS knob to 287 just to remind us which direction we're going, but we could spin that thing all day long and it's just going to give you a needle left or right of a magnetic course inbound on 287. But it's still using your VOR receiver. It's just a lot more sensitive. It's set up to be a lot more sensitive. That needle will move faster or move more for the same distance off. And you're going to get to the runway before you overfly the transmitter. So you're going to get to the runway and land before you overfly the transmitter. But those frequencies are also in here. And what starts at 118.0? What? Yeah, comm radios. Yeah, your communication frequencies start at 118.0. So there's two main components, ground stations and airborne equipment. Okay, great. We know about that. Ground stations, here's a picture of one. Who's not seen a VOR on a cross country? You look down, there it is. Okay. There's another one. The one north of the Prescott Airport. It's only about 10 miles away, so you see it a lot when you're flying out of that airport. One of the guys started calling it a cow church because he overflew it, and all the cows in that field that had a fence around it, they're all facing the VOR. All right, fine. Of course, we already know that they're aligned with the magnetic north when they're built, and there's 360-degree radials. Okay, great. Here's a nice one. And of course, you'll notice this one. What is the magnetic variation in this location? It's approximately what? If we scooted that VOR to the left, that is to the west, about a mile or about 2 miles. How much? I would have said 5, 10, 15. I'd say somewhere between 15 and 20 degrees magnetic variation. Okay. So, of course, this is just a reminder, VORs are bolted down to magnetic north, not true. So you can underline the word magnetic there. Of course, I don't want to go into the theory here too much, but it's a variable signal. Effectively, electronically, it rotates, and it's a phase differential, and I don't want to go into phase differentials today. Anybody want me to talk about phase differentials for 3 or 4 hours? Good. All right, service volumes. I can't remember. Y'all had somebody else for Private Pilot 2. Did y'all talk about service volumes? A little bit. Okay, well, now we ought to talk about them a lot. So let's talk about a high altitude VOR. If you need to draw this drawing on your paper, I think that'd be a lovely, lovely idea. So if you have a high altitude VOR, and way more than half of the VORs out there are high altitude. That's most of them are high altitude. So you'll notice that from 1,000 feet AGL to 1450, it's good for 40 nautical miles. So that means so let's take that as an example here. Let's talk about Clovis VOR. How far is Visalia Airport within 40 nautical miles direct line to Clovis VOR? It's probably pretty close. But hey, by the time we get to Visalia, we're going to crank in Visalia VOR. But if we get above 14,500 in our turbocharged PA-28 and we put on oxygen, between 14.5 to 18, it's 100 nautical miles. And that's the radius, okay? That's their radius, that's not the diameter. That is the distance from the transmitter. So if I want to use this VOR and have it good out to 130 nautical mile radius from the station, what class airspace am I going to be in if I'm getting 130 miles legal VOR service volume? Well, it's alpha, yeah. I'm going to be, if I'm somewhere between 18,000 and 45,000, I'm in class A airspace. Now, there's a couple of biz jets that'll go to around 15,000. Now, here's what's great. I want you to write this down because I don't think it's on the slide. If you're flying an official IFR airway, a Victor airway, or a jet airway, the FAA has already checked this for you, and you don't have to check it. So why don't you pull out your iPad and open up your low altitude and route chart, and let's look at it over the central San Joaquin Mountains.
Can you repeat that again?
Yeah.
You're flying
If you are on an FAA Victor airway, spelled V-I-C-T-O-R, a Victor airway, or a jet airway, then you do not have to check the service volumes to see if they're okay. The FAA, yeah, the service volume is what we're talking about. What's the volume of space you can be in and have it, and know that the VOR is going to work well. Because according to this, if I'm below 1,000 feet, I can't use this VOR for sure. So that's great news, because more than likely, if I'm flying, navigating via VOR, then I'm probably going to be flying on a Victor airway. Jet airways are up there in higher altitude. Pretty sure it's class A. We, in little airplanes, are only going to be flying the Victor airways. In fact, the identifier for the airway is going to start with the letter V, with the letter Victor. And I think if there's a dash, isn't there a dash in there, David? Is it like Victor-235 or something like that? Nope, just Victor 230. Okay, great. So if you look at Fresno Yosemite Airport, slightly to the left of it, you're going to see a black line coming in on your low altitude and route chart. Victor 230. If I'm flying one of these Victor airways, I don't have to worry about the service volumes. So really, the only time you have to be checking the service volumes is if you were flying a route, and A, you're navigating with a VOR, and B, you're doing it off of the airway. Let me say that again to remind you to write it down. The only time you as an IFR pilot are responsible to check the service volumes is when you are navigating with VORs and you're not on an airway. You're off of an airway. And those two, if you have both of those applying, you have to check the service volume of the VORs you're using to navigate. Yeah. If you're flying, if you're navigating with a VOR and you're off an airway, then you have to make sure that you're inside of the service volume of whatever VOR you're navigating. You have to check the service volume. This is very, very, very infrequent. And you'll notice I said navigating with VOR. What if you got a Garmin 430 and you push the CDI button and it says GPS? Are you navigating with the VOR anymore? Yeah, you don't really give a rat's behind about the service volume. But service volumes tend to be on written tests, and they can ask you on your oral exam. So there was the high, and here's the low. So you can, so you can draw a picture. And the terminal. There's. I'm trying to think. I don't know where the nearest terminal VOR is. There's not one in Fresno, Visalia, or Madera, or there.
I have a question.
Yeah.
So how come some VORs says the radios from this degree to this degree can't go farther than 10 nautical
You can't go
miles?
farther because there's terrain in the way.
Oh, okay.
So Jonathan's question, let's just say that VOR is on top of this table, and I'm flying out over here, but if there's a mountain on this table that gets in the way of the VOR radio signals, I'm not going to be able to receive it. So it's going to say, if you're further than this distance out, you need to be higher. Because remember, VOR radios are line of sight, just like COM radio signals. So that would also be a good thing for you to write down on your notes somewhere. VOR radio waves don't bend around at their surface like AM radio does, or ATX. So obstacles get in the way. Just like if you're on the backside of Camel Mountain, can you talk to departure control? Probably never try. That'd be kind of fun to deliberately descend down 1,000 feet AGL, get on the backside of Camel Mountain with it directly between you and Fresno. I'm going to guess, I don't know where their FM, their radio transmitters are, and give it a try. Maybe they got a transmitter somewhere else. Anybody have any questions on this slide? And nobody's ever going to use that stinking chart. I wouldn't worry about writing it down, but technically, if the VOR is down here at the bottom, you can figure out how high you'd have to be. If you're worried about this, you're probably going to crash into the side of a mountain or hit an obstacle anyway. That's my personal opinion. All right. Of course, VOR, airborne equipment. Of course, they blew it here. The pictures, that was me. I should have pushed the CDI button, so I got VLOC. And of course, here's some, I can't remember what radio this is. So airborne equipment is a receiver, and of course, CDI stands for course deviation indicator. We know lots and lots and lots about course deviation indicators. You notice the dots or the lines, each one is 2 degrees. Each one of those is 2 degrees. Yeah, when the needle deflects to the left or deflects to the right, like for instance. Okay. We got the OBS knob, the Omni bearing selector. Probably nobody will ask you what OBS is. And look, there's an off flag. It ain't working. And of course, the to from indicator, which we're very familiar with now. See if I think I've got pictures. Yeah, there's one kind of VOR antenna. There's 2 or 3. On mine, it looks like a towel bar. Mine was installed in 1969. People ask me what that is, and I tell them when I wash the airplane, that's where I hang my towels. They look at me funny like they believe me. Yeah. That kind of sticks out on the side. No handhold. That's on the side of the helicopter. All right, how do we use this thing? Okay, it shows our degrees, 2 degrees per dot or 2 degrees per line, whichever way you want to call it. Already covered that. Omni bearing selector, which radial or magnetic course you want to track. So this is probably the #1 issue, and sometimes I say it wrong in the simulator. This is the #1 issue I see people with using VORs, is confusing the radial you're on versus the magnetic course you want to fly. So you really have to understand where you are. Am I going to be flying to the VOR or away from it? And if you're going to be flying to it, then you need this. At all times, you're going to spin the magnetic course into the top of the CDI. The question is, now, if I'm going to it, I need to be looking for a to indication. If I'm going from it, I need to be looking for a from indication. I think we'll get more practice in the simulator. All right. Of course, to from, solving the ambiguity. Am I going to it or from it? And of course, if the nav flag comes out, you're toast. Hopefully the to and the from goes away. And of course, we already know this. After we go to the right frequency, we turn up the volume, we listen to the Morse code, and make sure it matches the VOR we're looking for. Common error. You're cranking in 115.6 and you really crank in 112.9 because your brain's not working right. And you just go, oh yeah, there's the Morse code, and you turn it down, and you're flying towards Friant instead of Clovis. So you need to look at the dots and dashes on the chart you're looking at and make sure you correctly identify it. Some VORs, they'll transmit high WAS data, and of course, you know, some VORs you can talk to the flight service station, and they'll transmit on the VOR frequency. Probably a better way to write this, instead of saying the OBS must match your heading, your OBS needs to match the magnetic course / direction you're trying to fly, because it only works for your heading if there's no wind. So you got to cross out the word heading. The OBS, the top of the CDI needs to match. Maybe that's a better way to write it. The top of your CDI needs to match the magnetic course you want to travel. And then, of course, I put that question in there. The top of the VOR will take me to the VOR if the to from indicator says to. Don't take any notes here, other than HSI. Somebody might ask you what's an HSI, so write down it's horizontal situation indicator. Horizontal situation indicator. And you don't have to write down what I'm about to say. I'm not going to ask you on the test. You're not going to fly an airplane with an HSI. I can't remember what's in the Frasca 142 as an HSI. Okay, well then you will be flying an HSI. The HSI, they take a deep directional gyro and they put a magnetic sensor out in the wing or in the tail, and then they slave the gyro to that magnetic sensor so you don't have to set it. I mean, you still have to check it every 5, 10, 15 minutes, but you don't have to set it. And then they put the VOR on there. You see that yellow line in there? You see how the yellow line is where that radio is. So that means if you're flying in that direction, you could turn left and start going towards that radio. So it's a lot easier to read than a separate DG and a separate VOR. It makes it a lot easier to read. All right, let's talk about limitations. We all know about the cone of confusion. You're flying over it, the needle starts to wiggle, the to from starts to flop around. Really all you know is, okay, I'm really close. What do you do when you hit the cone of confusion? You go, oh, I'm confused. Or do you pull out your phone and start watching Conehead skits from Saturday Night Live from the 1970s? That's what most of us do, is watch Conehead. You don't do anything. You don't turn. You just keep going. When do you know that you've passed the VOR? What on that thing says, I passed the VOR? When the to from needle flips and stays. As soon as you get a positive flip on your to from needle. All right, so that's all right up there. Oh, the zone of ambiguity. Woo-hoo-hoo. If you're off the center of this here with the black line, the dotted line, and the red X's, if you were anywhere to the left or the right of that where the dotted line is, it's trying to figure out whether you're going to or from. How often do you have that problem? If you're on that dotted line, let's just say to the right, the VOR is directly to your left. The VOR is going to have a hard time there deciding if you're to from. But how often are you doing that? If you're way off like that, you're probably turning towards the VOR and spinning your OBS knob and flying straight toward it. So if this is happening, you're probably making a mistake. Hey, I did put it in here. Yay! VOR radios are line of sight, and of course, terrain or obstacles can get in the way. And that's part of why the service volume gets bigger when you go up in altitude, is because you can get away from terrain obstacles, and you can mitigate some of that curvature of the bird. You ever notice that when you go to the beach, you can't see Hawaii with a really good pair of binoculars? Does anybody ever look for Hawaii at the beach? No? Okay. All right, DME is a 3-letter abbreviation for distance. measuring equipment. Distance measuring equipment. DME is usually located at two kinds of places. One, they co-locate them at VORs. Like Clovis VOR has a DME. So I can fly the Clovis, I can fly the Fresno Chandler VOR DME approach as long as I've got VOR and I got DME. Because there's a DME transmitter out there. So I don't have to have a GPS. If I've got a VOR and I got a DME. Another place DME transmitters are located, there is one at the Fresno Yosemite Airport. So that if you're shooting an approach there and it requires a DME, they got a transmitter. At least I think they got one there. So somewhere, this is the VOR antenna, that's probably the DME antenna over there on the left. This is a standalone DME transmitter. There's usually, they paint it white and red so you don't hit it. It's usually off the side of the runway. It's usually off the side of the runway somewhere. And the taller thing with the lights on top, that's the DME antenna. Oh, there it is, DME. Wow, it's like I knew this already. All right, so let's see if I can cover the way DMEs work. You're flying along in your airplane, you have a DME transmitter and receiver. If you look, you don't need to pull it out, but if you look at that approach plate, it's a DME channel 76. So if you had a DME receiver, you crank in 76. That's not really the frequency, that's just what they call it. You know, it's like it's in the 1,000 megahertz range. That DME, every so often, it sends out, it's multiple times per second, it sends out a short burst of a signal that lasts like, you know, a millionth of a second. And any DME receiver on the ground that gets it, it's tuned to channel 76, so they found every one, it's going to wait a certain amount of time, and it's going to send a signal back. The DME receiver in the airplane, that amount of time it waits, that's standard across all DME transmitters. It's going to take that time it takes to get there and the time it takes to get back, which is a really small amount of time. Remember, it's traveling at the speed of light, right? It's going to measure that and figure out how many miles away it is. I'm not making this up. There's somebody with a plastic pocket pen protector and a slide rule in the 1940s that was really smart. Figured out how to make electronics that could measure really, really short periods of time. When it gets that signal, it's going to send out that signal it sends out. It's responding to the signal you sent. That signal from your airplane has a certain piece of data on it. So when it sends the code back out, it sends that data on the front of the signal. So your DME is the only one that's paying attention to it. Because otherwise, if 5 other airplanes are around, that thing's sending out DME all the way around. You would never know if it's 5 miles or 10 miles or 12 miles or whatever. So that it's really what it's doing is it's interrogating going back and forth. So the signal is specific to your airplane. When you look, yeah. Okay. Now, if I got it, here's our limitations here. Don't worry about the accuracy of DME. If we're using DME, we're going to fly it. We're not going to be using DME. Are we going to be flying a little airplane worrying about DME more than 199 miles away? Probably not. You can get, so in LA, this might be an issue. In LA, if 100 airplanes tune in one DME channel, and they're all capable of receiving it, they're high enough to get to it, that 100th one, it won't work. But that's very seldom the case because they got a lot of different DMEs. You're really just going to set it to the VOR or the airport you're going to. And then, of course, slant range. When I say slant range, and it tells you, here's our DME transmitter, and here's our airplane. If the distance to you and the airplane, or from the transmitter, is 10 nautical miles, this distance right here might be 9.9 nautical miles. This is called slant range, and that's what you read. And that's, you don't worry about it. If that's what it says on the approach, it's taking that into account, and you fly it. If there's a little bit of difference, now what if you have GPS? Guess what? Your GPS distance is going to be this down here. But the difference is so little, we don't care. The difference is so little, we don't care. And of course, with DME, it's line of sight because it's a really, really, really high frequency, and hopefully that's, oh, there it is. Okay, we're almost done here. We already talked about that, and who cares about that slide? So we'll start up on this slide on Monday. And what day is the test? Tuesday is the test. What's going to be on the test?